Hi, in this video we're going to talk about solving very basic trigonometric equations. What makes trigonometric equations unique when you compare them to other types of equations, the periodic behavior of every single trigonometric function creates multiple solutions. So let's go ahead and start with this problem, sine x equals 1/2. So where is that going to happen? Well, if you think about the unit circle, we know that's going to happen when the angle is pi over 6, right? And we also know it's going to happen when the angle is 5 pi over 6. Then these functions going to have period of 2 pi. Right? So just to give you an idea, we're going to hit that point here. We're going to hit this point again here. But then we hit it again here, and another one here, and another one here, and etc., etc., and then going this way as well. Okay? So what does that mean? So we can take pi over 6 and we add 2 pi n, where n is an integer. That's going to give you a set of solutions. It's going to be this point, that point, that point, that point, another point here. And also it's going to be 5 pi over 6 plus 2 pi n. So it's x equals, n is an integer. Okay, moving on. Sine x equals -1. Where does sine reach the value of -1? There's one point here at 3 pi over 2. Then it will repeat itself again every 2 pi. Because it reaches one of the extreme values, because it's the lowest value that sine can attain, then it's going to be only one point like that, but it's going to repeat every period. So we're going to have, this is 3 pi over 2, and our solution is going to be x equals 3 pi over 2 plus 2 pi n, where n is an integer again, and it's going to give us that. Sine x equals 0. Well, when sine x equals 0, that's going to happen at 0, but then it happens again at pi, it happens again at 2 pi and 3 pi. So that one value is going to be attained at each one of these points, and it's also going to repeat itself every pi. Even though the period of sine function is 2 pi, these values are going to repeat every pi. So if you write 0, then you have pi, then you have 2 pi, you have negative pi. All that's going to fall under this. It's going to be pi n, where n is an integer. Okay. 2 cosine x equals -1. So the first thing we need to do is leave cosine by itself. So it's cosine x equals -1/2. We divide both sides by 2. And now we can go ahead and do it. Where is the value of cosine going to equal -1/2? It's going to happen at 2 pi over 3. And it's also going to happen at 4 pi over 3. So we take each one of them and we add 2 pi to it. So 2 pi over 3 plus 2 pi n. And x equals 4 pi over 3 plus 2 pi n. Cosine x minus 1 equals 0. First, let's rewrite that. Cosine x equals 1. Where does that happen? It happens at this point, and then at each point over here. So it's going to happen at 0. It's going to happen at 2 pi. It's going to happen at 4 pi. It's going to happen at -2 pi. So these can all be described as 2 pi n. Example 6, tangent. So remember, tangent, the period of tangent is pi. And also tangent, the graph of tangent is the one that goes like that. And what happens is it's not going to have up and down like sine and cosine do. So it's a little bit easier in the way. Where is tangent going to equal 1? Tangent equals 1 on pi over 4. It's going to repeat every pi. So the answer here is going to be x equals pi over 4 plus pi n. Tangent x equals negative square root of 3. Where is tangent going to be negative square root of 3? That's going to happen at 2 pi over 3. And it's going to repeat every pi, so the value of x here is going to be 2 pi over 3 plus pi n. Okay. And tangent equals 0. Where is tangent 0? At 0, and it's going to repeat every pi. So here the answer is going to be x equals pi n. Okay. We'll do another video where it's going to go into more depth with some problems that you may run into, but that's just the introduction. Okay. Hope this was helpful.